Hello, great students. My name is Jimmy Gabriel. You are welcome to Math Class once again. Today we'll be talking about square and square root. But before we continue, here are the objectives of these topics. Now, square root. What do we mean by square root? Last time we talked about indices, where we say 7 square can be written as 7 times 7. This we call index form. Why this we call expanded form. Now, in other words, the square of 7 is 49. That is, 7 square equals to 49. The statement can be turned around as the square root of 49 is 7. That is, this symbol is called square root. Now, the square root of 49 equals to 7. That is, moving from this side, which is 7 times 7 equals to 49, then we use the square root to move back to the square of 7. Now, this sign means the square root of. I can have something like this. I say the square root of 4. That is, this sign means square root. The square root of 4 equals to 2. To find the square root of a number, first find the factors. For instance, 4. What are the factors of 4? And we know 1 and what? 2. That is, 1 can divide 4 and 2 can also divide 4 without remainder. Now, example. To find the square root of any number. Now, method. Try prime numbers. We know our prime numbers starting from 2, 3, 5, 7. When you start with 2, when you see that 2 cannot divide the number, you move to the next number, which is 3. And 3 in 11,025, you have 3, 6, 7, 5. What can go again? 3 can also go again. 3 in 3, 6, 7, 5, you have 122. 5 can also go, so you go to 5. 5 in 1, 2, 2, 5, you have 245. 5 can also go again. 5 in 245, you have 49. Obviously, 5 cannot go again. You move to the next prime number, which is 7. Now, 7 in 49, you have 7. What can go again? 7 in 7, 1. Now, look at. These are the factors of 11,025. This can be written as 3 times 3 times 5 times 5 times 7 times 7. If you are to write this in an index form, this is what you will have. That is 3 raised to power 2, 5 raised to power 2, and 7 raised to power 2. What you need to do here is that you pair them together. You take one of these 3, one of this, one of this. Another pair, 3 times 5 times 7. You can see 3 times 3, 5 times 5, 7 times 7. You just pair them in groups so that you have each pair multiplied together. That will be 105 times 105, which is equals to 11,025. Just like the case of 7 raised to power 2 equals to 49. Now, to move from 49 again to 7, that means you find the square root equals to what? 7. Now, we have 105 times 105. Now, the square root of 11,025 will be equals to 105. Another example is find the square root of 6,400. You can simply write this in standard form. 64 times 100 will be equals to 6,400. Now, you can write this in form of square. 8 times 8 will give us 64, and 10 times 10 will give us 100. Now, when you have 8 times 10 times 8 times 10, you have a pair. Now, when you pair them together, you take one of it, that will be 80. That 8 times 10 equals to 80. Now, the square root of 6,400 equals to 80. Now, 80 square will also be 6,400. Now, another example. Find the square root of 225. Now, using our prime numbers 2, 3, 5, 7. 2 cannot go in 225 without remainder. 3 cannot go in 225 without remainder. 5 can go in 25 without remainder. Now, 2 cannot divide without giving us remainder. 3 cannot divide 225 without giving us a remainder, but 5 will give us a whole number. Now 5 into 25, you have 45. 5 can also go again. 5 in 45, 9. What can go again? 3. 3 in 9, 3. 3 in 3, 1. By the time you write everything out, you can see you have them to be perfect square. That is 5 times 5 times 3 times 3. Now you pair them. 5 times 3 times 5 times 3. You can see that this is what you have here. Now the square root of 225 will be the multiplication of one of the pair, which is 3 times 5 equals to 15. Now 15 times 15 will give us 225. That is how to find the square root of any number. You first of all find the prime number, the factors, by using long division. Now perfect square, you can see that 3 square is same thing as saying 3 times 3 equals to 9. 5 square is same thing as saying 5 times 5 equals to 25. Now look at this side. The square root of 9 equals to 3. It's just like the reversal of what we have done here, or like opposite. Now to move from 3 square, we give us 9. Now to move from 9 to give us 3, you use square root. Now when a number, we say that 925, 625 and 225 are perfect square because their square roots are whole number. That is, when you find their square root, you have whole number. We call them perfect square. A perfect square is a whole number whose square root is also a whole number. Now it is possible to express a perfect square in factors even with indices. I believe you remember when we're talking about indices. Now 9216 can be written as 96 times 96. When you multiply this, you have this. Definitely 9216 is a perfect square. Now I can simply break down 96 again into 3 times 32. 3 times 32. 32 again can be written in an index form. You know, 2 times 2 times 2 equals to 8. Times another 2 is 16. Multiply by another 2 will give us 32. 1, 2, 3, 4. When you write the whole of this in an index form, you have 2 raised to the power 5. That will be 3 times 3. 3 times 3 times 2 raised to the power 5 times 2 raised to the power 5. From our indices, we know that 3 raised to the power 2, 2 raised to the power 5 times 2 raised to the power 5 will give us 2 raised to the power 10. Now, the whole of that of 9216 can be written in an index form, which is 3 raised to the power 2 times 2 raised to the power 10. Now, example. Find the smallest number by which 540 must be multiplied so that the product is a perfect square. Now, look at 540 is not a perfect square because when you find the square root, it will give us a decimal number. But what can we multiply with 540 to make it a perfect number? Now look at, the first thing to do is you find the factors using long division. Now starting from the lowest number, which is 2, from our prime numbers, use 2 first. 2 in 540, we have 270. 2 again. Now these are the factors when you use long division. Now bring it out. 2 times 2 times 3 times 3 times 3 times 5. Only 2 and 3 are even number, are even. They can make a pair. But we have 3 and 5 left, which happen to be single number. Now, what can we do to make this 3 to become like this 2 and this other 3? Definitely, we multiply another 3 with it. The same thing with 5. We multiply another 5 with it to make also a pair. Now, after doing that, how many number do we multiply? That means we multiply 3 and 5. That means when we multiply 15 to 540, it becomes a perfect number. That is, the result of this is a perfect number. That is how to make any number a perfect square. Now, find the smallest number to make this and this a perfect square. Now, look at We have them paired. Then we have this also paired. Now ignore this. Let's use this question. This is it here. 2 times 2 times 3 times 3 times 7. Now you can see this one, they are paired. Only 3 and 7 can be paired. Now what can we do to make them to be even like the other numbers? Now that means we have to multiply 3, then another 7 to the number to make them paired. That means the number we multiply is 3 and 7. Now we have 3 and 7 here. That means we need another 3 to join with this up one to make it even. We need another 7 with this to make it even. That means making two numbers. That means the number which we multiply is 3 times 7. Now that is 21. Now look at this also. 2 raised to the power 4 times 3 raised to the power 3 times 5 times 7. This one is even already. This one is 3 times 3 times 3. When you remove 2 out of it, it remains 1. That means only 3 times 5 times 7 can be paired because they are not even. Now that means we introduce 1 3, another 5, another 7 to make them paired. Look at. Now these are the number with which you multiply to that number to make it a perfect square. Take it to 18 again. 2 raised to the power 4 times 3 raised to the power 3 times 5 times 7. Now when you write this one in an expanded form, it will be 3 times 3 times 3. When you remove even from it, it means only 1 3. It will remain 3 times 5 times 7. That means we need one more of 3, one more of 5, one more of 7 to make them even. That means we have to multiply 3 times 5 times 7 to make it an even number. Now to find the square root of fraction, how can we find the square root of fraction? Look at this. Is the first example. When you have something like this, 4 all over 25 can be also written as 4 square root of 4 all over square root of 25. Square root of 4 is 2. Square root of 25 is 5. Now the second part, you reduce to the lowest form. Now 27 over 48. 3 here 9, 3 here 16. Then you now find the square root of 9. Square root of 16 equals to 3 all over 4. That is how to find the square root of fraction. First of all, you reduce it to the lowest term, then you find the square root from there. Now, when you have mixed fraction, the first do is that you express the mixed fraction as an improper fraction. 5 times 9, 45 plus 4, that is the square root of 49 all over 9. Like I said before, you split them. That is square root of 49 is 7, while the square root of 9 is 3. Now your answer is 2 whole number 1 all over 3. Now assignment for you. You have to find the square root of these two numbers, then find the smallest number by which you can multiply to make this following a perfect number. Then find the square root of the following fraction. Now these are the summary of today's topics. Now for further reading and more exercise, get your JS2 textbook mathematics from page 23 to 26. Till I come your way next time, enjoy your day.